Hey everyone, so this is question number 1, section 14.4, which is inferences about population regression coefficients. Alright, so in this section we have two formulas, and the first one is the test of hypothesis. Alright, so we need to calculate the t-stat. We run the testing, the null hypothesis 80 is going to be the beta is going to be 0 versus the beta is going to be different than 0. So here it means just the slope, whether it's equal to 0 or not. All right, and obviously we want this. We want this part here, the different than 0. All right, in order to have a regression. So the perfect scenario would be always to reject the null hypothesis. All right, so we're going to go through the step in a moment, and as well we have the confidence interval formula, and over there we just have to plug it in and figure out the lower end and the upper end of the interval. Okay, let's start with the problem, and this video might be longer than the subsequent one because I'm gonna go in details and explanation. All right, so hang in there. Okay, so for the first question we are giving the n, the b1, the b2, the sb1 and sb2. So the b1 is the value of the slope. All right, so that's 10. The n is the number of the variables, 45. And the SB1 is the standard error for each one of them. And we are comparing which one of the variables has the largest slope. Okay, so for this one, I created an Excel spreadsheet, and I'm gonna fill it up together. And this is gonna serve us as well for the next questions. All right, so let's start with the first part of the table. So here is really simple. We just have to fill up the table here. So we have a 45k is going to be 2 because we have two variables, b1 and b2. Now b1 is 10, 15 for b2, and then 4 for sb1 and 10 for sb2. Now what we're going to do is we just have to apply the formula. So I'm going to apply it for the t-stat, the first one, right? So this is my formula, and what I'm doing here, I'm calculating the t-stat. So t-stat according to your formula is b1 minus beta 1 divided by sb1. So now just you have to consider beta 1 always 0, so the beta j is 0, right? So this will become just 10 divided by 4, all right? 10 is over here and 4 over here, right? Okay, so this is going to give you 2.5. Now we can generate this on Excel. It's really simple. Just double click here. It's going to be equal sign. Click on B1 divided by the SB1 and all set. And you can do the same thing with t-stat 2. So you're going to be equal sign and click on the 15 divided by the 10 over here. All right, and that's 1.5. Now since 2.5 is greater than 1.5, then we're going to go with the x1 has a greater slope. So we're going to select x1 here, we check, and we got it. Now for the second part, we need to construct the confidence interval, the 95 percentile confidence interval. So let's do it by hand first. Okay, so this is my formula. So the confidence interval is basically you want to figure out the lower limit and the upper limit. All right, according to your formula, the lower limit is going to be for b1, right? it's going to be B1 minus T alpha over 2 times SB1, all right? And you just have to plug it in and figure out the value. Regarding the upper limit, you're going to be B1 plus, instead of minus, T alpha over 2 times SB2, B1, sorry, SB1, right? Okay, so we have everything except the T alpha over 2. So now on the chart here is telling you that if this is 95%, if this value is 95% here, so that's in the middle, these values over here are going to be 0.025. Now, what is the formula behind it? So obviously, this is the half of the alpha. Both values here, these both areas will constitute the alpha value. All right. So the sum of these two tails, it should be alpha because you are in two tails mode. Now, how do you get it? Is always you do 1, that the total area of the bell shape, minus the middle area, which is the green one, 0.95, divided by 2. And that's going to give you this value in here. So the formula is 1 minus the confidence interval divided by 2. Okay? And the value we're going to look for it in the table. And before moving to the table, we need a degree of freedom, which is this one. In this case, the n is 45, the k is 2, and minus 1, that's going to be 42. All right, so my degree of freedom is 42. My alpha over 2 is going to be 0.025. So let's go to the table. Okay, so this is my table. We're gonna focus on this value here. This is the value of the alpha, and the degree of freedom, you can see it here, we can read it there, right? So we can keep going all the way to 42. Okay, 42 is right here, so we can go horizontally, and the value we are looking for is just right here, 2.0181. Okay, going back to the chart, so this is 2.0181. the SB1 is 10, so this is going to be B1, which is, oh, the SB1 is 4 here, sorry, and the B1 is going to be 10. So this is going to be the upper limit. The lower limit is going to be 10 minus 2.0181 times 4. Now you could plug this in the calculator and you get the answers here, right? So this is your confidence interval. Now what I'm going to do, I'm going to construct everything on Excel, so like that I can go faster with the next questions, right? So starting with the B1 here, so I'm going to do equal sign and then click on B1 value, enter. So the confidence interval here, you're going to change, so 0.95. Make sure you change it from one exercise to another. Now here I'm going to plug the formula that you see it right here. So this is my formula that I'm going to plug it on Excel. So this is going to be the alpha over 2. So open a equal sign, open a parentheses, and you're going to put 1 minus, click on that cell, close the parentheses, and do divide by 2, enter. And that's the value of alpha over 2, right? Now the n is going to be a 45. We said this one is going to be equals to 42, but we can make a formula for it. So click on this, minus 2 minus 1, right? SB1, we can put equal sign here. So, and click on SB1 and enter. Okay. So we're going to go back to the decision in a moment, right? is not this section. So to find the T alpha over 2, we are not going to use the table. We're going to use a built-in function in Excel. So we're going to put equal sign and then T distribution dot inverse function. All right, so we're going to use the first one. So the probability that you're looking for here, so you are going to give to Excel all the left tail, which mean I'm going to draw it here. So you're going to give it all this tail from here to here and ending this way. So what you're looking for this value, that's the T critical, or T alpha over 2. All right, so what do you have there? You have the value of 0.95 plus the value of 0.025. So that's the probability you're looking for. So you're going to put the sum of this. So you can put sum, open parentheses, and you sum up these two together. All right, close the parentheses, and then degree of freedom. Degree of freedom, you're right here, 42. You click on it, close the parentheses, and enter. And you see we get exactly the same value, right? So for the lower end, we're gonna put equal sign, and we're gonna follow this formula, right? So we're gonna click on B1, which is this one, minus sign, click on the T alpha over 2, this one, times the SB1, which is 4, and enter. All right, and make sure there is a minus sign in between, right? For the upper end, we're gonna do very similar, equal sign, click on B1, which is this one, plus right now the T value multiplied by the SB1, and enter. And there you go. This should be your confidence interval. Let's plug it in and check it. So copy and paste. You want to round it to 4 decimal places. So this you're gonna make 76 into 7, and the same thing here. Round it to 4 decimal places and check. Great. Now it's telling us to make a decision according to the alpha level of significance, 0.05. All right, so first of all we select the null hypothesis. So for this, it's always the same. So this is my null hypothesis over here. So you are looking for H0 is going to be 0 and H1 different than 0. So this would be A. Now you're gonna find the test statistic, and the test statistic is nothing else than this value over here, which is T1, 2.5, if you see it there, right? So you just type it in, 2.5. All right, so now we are looking for the p-value. Okay, so we can use a built-in function on Excel, and that equal sign, since we are using the T distribution, so it's going to be T dot distribution, and we're going to use the right tail. So now he's asking about the X value, and the X value is going to be 2.5. And then we're going to put degree of freedom, and we can choose the degree of freedom here, which is 42, right? And that's basically it. So now we get this value here, which is not exactly the p-value we are looking for. Since this value, whenever you use the RT, so this is my normal bell shape, and this is basically the 2.5 where it's located at, right? So here is 0. So this is my T t-axis. So what is the p-value? The p-value is the threshold here, the tail that ending with 2.5. And as a matter of fact, since you are using a two-tail distribution, so the p-value is both tails together. Alright, so if I had minus 2.5 here, the sum of these two areas will be called the p-value. Alright, and again it's related to t-stat, not the t alpha over 2, right? Now whenever I used the right tail and I gave 2.5 as reference, the calculator will give me this is this area over here only. Let me put it in blue. Only the blue area is actually 0.008. In other words, this is half of the p-value, right? P-value divided by 2. Therefore, to fix it, you need to add another multiplication here, 2 times that formula, right? And that will be your t-value. So let's verify it, copy it, paste it, and round it to 3 decimal places. And let's see, and we got it. Okay, so now it's asking you whether you're gonna accept or reject. So we are going back to this null hypothesis and we're gonna make a decision, right? Whether it's the value b1 is gonna be different than 0 or not. So to make this decision, there are two ways, all right? Either comparing the t alpha over 2 versus the t statistics, which is this one. So in other words, if the t stat is bigger, then we're gonna reject. So remember, this is my t stat here, and the threshold was in 2.0. This is t alpha over 2, right? So this is the separation between the accept and reject. So here, do not reject, and right here is reject, 80, right? And that's what we want. We want the t stat to fall in this area, all right? So we are rejecting. The other alternative is what we can use if p value is less than the alpha value, then here reject, 80. And you should use this as a formula as well. Alright, and if you reject, there is sufficient evidence. Alright, okay, so we can put this on Excel as well. So the null decision according to null hypothesis, you can use the if statement, equal sign, and you put if, open a parentheses, and what you're going to do here, you just compare the p-value. So p-value, if this one is less than the alpha, which is 0.05, comma, and you put your statement, reject, 80, and you can put even sufficient evidence. Alright, close the quotation, and on the other end you're going to open another quotation. So this is on the opposite scenario. If I didn't have that statement, p-value is smaller than alpha, what I'm going to do not reject, 80, right? And if you did not reject, you can say insufficient evidence. Close the quotation, close the parentheses, and enter. And you see here I end up with reject 80, so the comparison is done automatically. All right, so now let's go back to the exercise. So yes, here there is evidence that the variable x1 contribute to the model, and that would be yes. And why? Because we reject the null hypothesis, right? The null hypothesis reject. And here we're gonna do all over the process, and we're gonna do it with beta 2. So we start with beta 2 equals 0 and beta 2 different than 0. That's A. I think that's A is the best choice. And we're gonna find the statistic, t statistic, and which is 1.5. We have it already. 1.5 here. And we want to find the p-value as well. So for this we can do the p-value. So here it's going to be 2 times t dot distribution, and you use RT. The x is 1.5, click on that one, comma, the degree of freedom, you can put it 42, although we didn't fill up this, you can use 42 there, enter, and that's going to be 1.14. Okay, round it to 3 decimals and check it. Great. Now obviously 0.1 is greater than 0.005, right? Can copy this decision and put it right here, double click on this, so that's the same cell, is fine, and compare it to 0.05, and we can see the statement here, do not reject A0, insufficient evidence. So do not reject, that means we don't have a good correlation. So here it's saying, is there evidence that the variable x2 contribute to the model? And no, there is no evidence, and the reason because we did not reject A0, right? So no, since the null hypothesis is not rejected, that would be B. Now one of them was good for us, we see the x1, and the x2 was not a good one, right? So definitely we are not going to keep x2, all right, which we reject the null hypothesis. We're going to keep only the variable x1, that is, we have evidence that the slope is different than 0, therefore contribute to our regression, right? So here we're going to include only the variable x1, it should be D, right? Okay, all set.